Let's talk about elastic and inelastic collision in this lecture. So we have talked about conservation of momentum, and we have also talked that if you have a system in which, let's say, you have two balls, and let's say this guy has momentum p1, this guy has momentum p2, then if they collide and say, let's say, rebound backwards, so this is p1 prime and this is p2 prime, then p1 should always have arrows on top of vectors equals p1 prime plus p2 prime. So we did talk about collision, but we didn't really explain it in a deeper way. So this collision can actually be categorized in two ways: elastic and inelastic. Where elastic collision are those for which energy remains conserved. And inelastic collisions are for those for which energy is not conserved. Okay, so if this guy is moving forward and this guy is moving in this direction, let's say this is moving with velocity v1 and velocity v2. Let's talk in terms of velocity, because velocity is a representation of energy. We know that kinetic energy is given as half mv squared. So the energies is half mv1 squared, m1 v1 squared, and half m2 v2 squared, given m1 and m2 are the mass of this object. But what we are talking about is that if these guys collide and rebound backward such that half, let's say this is the initial state and the final state is v1 prime and v2 prime, this is their new velocities. So if this is true, this is m1, this is m2, and if this holds true, that half m1 v1 squared plus half m2 v2 squared equals half m1 v1 prime squared plus half m2 v2 prime squared, which means energy remains conserved, then this we know is elastic collision. But if half m1 v1 squared plus half m2 v2 squared is greater than half m1 v1 squared v1 prime squared plus half m2 v2 prime squared, then this is inelastic. By inelastic, we means we lost energy. Where did we lose it? Well, we lost in heat and sound, or some place we don't know. Mostly heat and sound. So we lost some energy in the collision. But here we did not lose it. So this is an elastic collision and this is an inelastic collision. But what about momentum? Is momentum going to stay conserved in both of them, or is it going to follow different inequalities or different situations for two kinds of collisions? Well, momentum will always remain conserved. If there is no external force, momentum will always remain conserved, even if it's an elastic collision or it's an inelastic collision, which can simply be understood from this formula: F equals dp over dt. This formula does not even talk about what elastic or inelastic collision. It's a formula in itself. Okay, so this is so momentum remains conserved all the time. That's always the case.